Hello, today we are going to talk about an application problem based on the exponential decay model. So let's consider an example. A certain radioactive isotope is a byproduct of some nuclear reactors. Due to an explosion, a nuclear reactor experienced a massive leak of this radioactive isotope. Fortunately, the isotope has a very short half-life of 4 days. Estimate the percentage of the original amount of the isotope released by the explosion that remains 3 days after the explosion. So we have given the half-life of this substance. So half-life of a substance is the time required for half of the given sample to disintegrate. So if you assume the original amount as say sub 0, then after a period of like 4 days, the amount becomes 1/2 of a sub 0. So here we can consider the decay model as exponential decay model as A of t equals A sub 0 e to kt. So you have seen some problems based on the exponential growth model. So there we use the letter P of t equals P sub 0 e to kt. So you can also use the letter A of t equals A sub 0 e to kt. And A sub 0 is the initial amount. A of t is the amount or the quantity after a period of time. And for this case, K is the decay rate and T is the time. So we can consider the original amount as A sub 0. So since we have given the half-life like 4 days, so after this 4 days, the amount becomes 1/2 of A sub 0, 1/2 A sub 0. So A of t is 1/2 A sub 0 equals the original amount is A sub 0 e to k times the time is like 4 days. T is 4 days. Now, first we need to solve this equation for k. So you can see that this is an exponential equation. To solve the exponential equation, we need to get the exponential part by itself. So divide both sides by A sub 0. So we can see that 1/2 equals e to 4k. Okay. Now we have to solve for k. So we have to take natural logarithm on both sides of this equation. So ln of 1/2 equals ln of e to 4k. Okay. Now we have studied one of the properties of the natural logarithm, ln of e to the x is x. So we can apply this here. So ln of e to 4k is 4k by using this equation. So ln of 1/2 equals 4k. So k equals divide both sides by 4. ln of 1/2 over 4. So the function that models the amount of the isotope at any time t is given by, so A of t equals A sub 0, substitute the value of k, that is ln of 1/2 over 4 times t. So the question is, estimate the percentage of the original amount of the isotope released by the explosion that remains 3 days after the explosion. So we have the model here, A of t equals A sub 0 e to ln of 1/2 over 4 times t. So instead of t, we have to substitute the value 3 to find the amount of the isotope left after 3 days. Okay. So A of 3 equals A sub 0 e to ln of 1/2 over 4 times 3. And we have to evaluate this value. So it is 0.59. So This is the original amount. So when we multiply them together, it is 0.59 A sub 0. So the amount of the isotope left after 3 days, we need to write it as the percentage of the original amount, that is 59%. So 59% of the original amount of the isotope released by the explosion, that is A sub 0 is the original amount, that is the original amount. So 59% of the original amount is left after 3 days. So the final answer is 59% of the original amount A sub 0 is left after 3 days. So hope you got this problem.